Well, as the title of the video says, we're working on the Wavetek model 187, right? If you want to see, let's say, the prelude to what I'm doing right now, which is trying to extract the electronic part from the cabinet so that I can work on it. If you want to see that, you can have a look at, let's say, the last 30 minutes or so of my last live cast back in October. Link below the video. Okay, so right now what I'm doing is I'm trying to release these little buttons you see here on front of the Wavetek by trying to gently unlock the Allen screw which holds them onto the shaft of the potentiometer. Yeah? For some reason neither of my Allen wrenches want to fit inside the screws, so I suspect the screws have been damaged. Now, why anyone would want to unmount and remount the buttons so many times the screws are worn out is a mystery to me. It turns out in the end that I did the right thing, namely releasing the main board from the 4 big standoffs below it, and then all it took was just sliding out the front and the back panel out of the lower plastic half of the case of the Wavetek, and there you go. This is the whole mechanism exposed. Alright, so if we take a look at the other side, then this is what we see here. So up there you have the main board with I think is the power supply, and then you have the switchboard, the lower switchboard right here. Fortunately for me, there's only one electrolytic, or maybe no, there are three electrolytics that need to be replaced on this board here, which is a lucky thing, so that won't be too much work to do. But the other board, the main board, has quite a few more electrolytics to replace. You know, and so there are a few tantalum capacitors to replace as well, and tantalum capacitors can be a bit of a problem. Alright, normally when you want to make sure some apparatus you bought works correctly, and it has a transformer feed, then you should make sure. Oh, hang on, I need to move you a little here. Okay, so can you see it? Yeah, you can. So normally what you should do is check a few elementary things, you know, like the fuse, for example. Wow, that's a hefty fuse. Okay, does it say what it is? Let me see. Wow, this is a peculiar fuse. I don't know if you can see it, but okay, can you see it? So there. See? This is a hefty fuse. This looks like a bimetal, almost like a temperature sensitive switch or something like that. It's really weird. Yeah, I've never seen something like this before, so I need to investigate what it is. Either way, let's see if it conducts or not. So let's have a look. Yep, it's conductive, alright. 9 milliohm. Okay, so it does conduct. So whatever it is, if we throw the switch, normally speaking, the Wavetek should function. What I would do is measure the primary of the transformer, but that goes through the power switch. Interestingly enough, the power switch is located at the back and is connected to the front of the Wavetek via a plastic rod. This rod here, in fact. Here we go. So that's one end, and that's the other end. And there you go. As you can tell, open lead. So it's open. Let's see what happens if I change the switch position. Nothing. Oh dear. Okay, false alarm. It turns out the power switch of the Wavetek is or was dirty. So if I switch it on now, well, there, you see, it's conducting. And before it was showing about 150 ohms. Now it's already dropping to somewhere around of about 80 ohms. Okay, as you could tell, I detached the whole back plane of the Wavetek, including the transformer, alright, from the rest of the Wavetek. Okay, so in effect I disconnected the power wires of the secondary that go to the main board of the Wavetek. Well, on the one hand, because it makes it a little bit easier for me to test it all out to see whether it works or not, and that way I can desolder the parts on the main board a little bit easier. Okay, so now that I've got the transformer released, as it were, from the main board, let's check if the secondary is still good. So it has a secondary winding with a center tap, you know, for the main board, which, okay, yeah, that looks to be okay. Yes, I don't know if you could see that, but you know, so if I measure from end to end of the secondary, it's okay. You can see it on the dial of my multimeter. Okay, so yeah. So end to end it works, and then from one end to the center tap works as well, and from the other end to the center tap works as well. Okay, so I read the schematic, so I think the secondary, the main secondary for the main board is probably around, I think, 25 volts AC. Okay, possibly more, maybe even 30 volts AC, because inside or on the main board of the Wavetek, they split it into two parts, you know, two power rails, one of plus 15 volts and one of minus 15 volts. Okay, so that's why I'm guessing the AC on this secondary is measured from the center tap to one of the ends is 15 volts. Yeah. Which allows for making a symmetrical power supply. And then you have a smaller secondary, which is this sky blue wire here. Okay, and that is supposed to generate around about, I'd say, 8 or 9 volts AC. Let's check if it works. Ah, there you go. Aha, okay, so there's the problem. Or maybe not. No, okay. Yeah. Oh, okay, so no problem. So this secondary works as well. Okay, so, and my guess is, since this is the AC power supply for the 5 volt DC, what I'll do next is replace all the capacitors on the main board, the electrolytics, and once that is done, then we can move on from there. Alright, instead of resoldering the 30 volt center tapped wires back to the main board as it used to be, I opted instead for installing a connector, and I obviously installed the appropriate male connectors that fit inside these here on the wires of the transformer, and I did that because in the future, if the Wavetek needs some servicing, then the power wires and the whole backplane, in fact, can be disconnected from the main board, which makes maintenance way much easier. And I did the same thing for the 5 volts side of the power supply. Yeah, and I obviously installed a smaller connector here. Alright, I'm going to replace these two capacitors first, and as you can tell, they are rated at 16 volts 100 microfarad. Now I want to draw, hang on, I want to draw your attention to the leads here and here. Okay, so you can tell that they are quite corroded, right? So I suspect that these two capacitors are not too good anymore and needed replacing anyhow. Obviously I'm going to replace the other capacitors as well on the board, but still these two more than likely need replacing. So, and I'm going to replace them by capacitors which are rated for 100 microfarad 63 volts. Now the voltage of the capacitors doesn't matter that much, at least not in this kind of voltage range, I don't think. So it doesn't really hurt to replace them with capacitors which are rated slightly higher voltage. Now obviously the one big difference is that these are I forgot the name actually, but let's say longitudinally connected, while these are radial. Okay, so where these are lying down, these will stand up, but the capacitors are really rather small, so it doesn't really matter. It won't bother anything. Alright, this capacitor measures 92.5 microfarad and has an ESR of 730 milliohms, let's say. Not great, but not bad either. This capacitor measures 89.4 microfarad and the ESR is around about the same, 735 milliohms. This is what a new capacitor measures like. There you go. A new capacitor measures 90.4 microfarad and an ESR of 280 milliohms. Now, for those among you who are new at this, at electronics, electrolytic capacitors have a polarity, okay, and that's really important. So it really matters how you mount them on the PCB, okay. So before removing them, you should take note of how the original capacitors were connected. Now the cathode, or the negative side, is often indicated by, let's say, an arrow or a full dark line indicating the negative. You see, right here. So this is the negative end, or the cathode. Obviously the other side is then the positive end, or the anode. Now this may differ from capacitor brand to capacitor brand. For example, this capacitor, the negative is indicated like this, okay, and it also has a short lead. Now in modern capacitors, often the cathode, or the negative side, is indicated by the shortest of the two leads. The positive side always by the longest one. Okay? Now, this is what it should be in 99% of all cases. But in all the years I've been restoring stuff, electronic stuff, I did find a few electrolytics where in fact the line, the fat line there or here, indicated the anode, or the positive side, and not the negative side. So it's really important when you unsolder, or before you unsolder the capacitors, is to take note how they are mounted and also what is indicated on their sides. Okay, so never take a capacitor at face value. Okay, so never think, oh okay, there's a fat line, that's the negative. No, you should always check, especially in older equipment. The capacitors in the power supply area, the main area of the power supply, have been replaced, so 6 in all. Unfortunately, since these are radial capacitors instead of axial, I had to J-hook them into place, instead of well, directly being able to solder their leads. But you know, whether you J-hook a capacitor or you solder them directly to the copper circuit, it doesn't really matter as long as the J-hook is solid enough. Electrically it really doesn't make any sort of difference. It's not as pretty, aesthetically speaking, as a lead extending all the way to the contact, but hey, you know, we're not going to watch the interior of the Wavetek while using it, so who cares, right? As long as it works correctly. The other capacitors are also radial capacitors, so not actual, but that doesn't matter. Their size is small enough to stand up on the print board instead of being placed lying down, so to speak. So yeah, I'm done with this area. Now I need to move to the complete opposite corner of the main board, and there are a few electrolytics down there I need to replace, and one single one over there. Alright, and then the other board, which is located below the main board, which by the way is called the pulse board on the schematic. That one has, as far as I can tell, only 3 capacitors to replace. So yeah, we're nearly there, and once we're done with that, the only other thing I'm going to replace is the light bulb, which I unsoldered from these 2 contacts here, E33 and E34. Alright, I'm going to replace that by an LED, remember? And when that is done, then I think we can reconnect the transformer and give the Wavetek a preliminary test, so to speak. Alright, I replaced all the electrolytics on all the boards, well, on both boards, and well, in the main, most of the electrolytics were still quote-unquote good. They would have been serviceable for yet another few years for sure, but since I'm in here, I'm going to replace them anyhow. Okay, I don't want to, once this is repaired, I don't want to reopen it anymore unless it's absolutely necessary. Alright, I'm going to give the Wavetek a test run. But before that, I wish to say that I checked all the BNC connectors, and all except one I could repair. Now the last one, the outermost BNC connector over there, see, right there, I could not repair. I mean, it's too far gone. It's broken. So I ordered a new BNC connector to replace this one. Now, what I'm going to do now is just some superficial test, let's say, just to see if there's some signal at the output of the Wavetek, and I'm going to use my oscilloscope to see if the Wavetek is generating signals. but I'm obviously not going to test for accuracy or anything like that. I just want to see if there's still some life in the Wavetek, and if there is, move on from there, and if there isn't, then I know there's still work to do, and I still need to well, I still need to figure out what's wrong with it. Yeah. So the first thing I'm going to do, hang on. The first thing I'm going to do is check the secondary AC power when I switch on the Wavetek, and I will of course also check whether the switch itself works or not, and the fuse works or not. But yeah, I would just want to check if the AC on the secondary, and I'm measuring over the two outer poles of the transformer, yeah, of the secondary winding, just to see if the transformer works, right? So okay, here we go. Okay, so let's see what happens now. There you go. 47.7 volts. Wow. Now that's a lot. I hadn't expected such a high voltage. Frankly, I expected at most maybe 30 volts or so. Okay, good, good. So it means the secondary works, and the AC switch, power switch, works as well. Okay, so let me reconfigure everything, put the camera on its tripod, and then we'll do a few checks with the oscilloscope. Here we go. I connected the oscilloscope to the output, which says low output, so which means maximum 2 volts peak to peak. Well, here we go. Okay. I'm not seeing much on the scope, I mean. Let's see. Frequency. Let's start with a 1-to-1 frequency. Okay. I'm not getting much. Let's see, function. Let's try a square wave. Yeah, I see something, but okay, let's see. Okay. I'm not getting much signal. See? See here on the screen? There's nothing much there. So I do auto scale. So yeah, there's something there, but not much. Well, now I'm not getting anything. There's no signal whatsoever. Okay. So I'm still measuring there. But the weird thing is, when I disconnect ground, you know, I'm not getting anything on the output except some very strange signal. Very, very, very strange signal. So this is what I'm getting without connecting it to ground. Okay. So that weird triangular shape. Let's see, what's the frequency of it? 50 Hertz. Okay. So what you see there is basically the AC that's surrounding us, but no signal. Oh dear. Okay, so there is obviously something wrong with the device. So far, all I can get out of it is sine wave. Okay, so sine wave works more or less. The highest frequency so far that I've gotten out of it is 3.77 megahertz. 3.77 megahertz is about the highest frequency I can get out of it. Also, the frequency is not very stable. Yeah. And actually it should be rock steady. So, and it isn't. So there's definitely something wrong with the Wavetek. Now, I also tried out the triangular wave, and that also seems to work. Okay, that seems to work as well, but only in the highest frequency range. If I drop in frequency range, let's see, what frequency is this? Okay, so this is 1.44 kilohertz. Okay, so that seems to work, but it's very erratic. Yeah, so it's not very stable, as you can tell. Yeah. It's all over the place. So this is 14 Hertz. Okay. So, and it goes up to almost 38 Hertz, and the lowest I can get out of it, let's see, the lowest visible is, my scope has trouble finding it, is 2.4 Hertz. So triangular wave works, sine wave works practically in all ranges, but it's very erratic, it's not stable at all, but square wave, yeah, square wave, I don't know, let's see, in a higher frequency range. Yeah, no, square wave is a no-go, apparently. All I get out of the scope is a continuous DC signal, and that's it. I suspect one of the reasons why the Wavetek isn't working well is due to bad contacts in the switch banks of the Wavetek. So what I'm going to do first is I'm going to give all the switches and the potentiometers a cleaning with contact cleaner and see if that helps to, let's say, alleviate some of the problems. If not, then I suggest we have a look at the square wave generation part of the Wavetek. So I cleaned all the switches and all the potentiometers on the main board and on the pulse board, which is how it's called on the schematic. And the way I understand this is that the square wave pulse is being generated on the main board, but is then sent, let's say the basic pulse is being generated on the main board, but is then sent to this board where it's shaped, as it were, you know, and where all sorts of settings pertaining to square waves can be set. So on the pulse board you can set all sorts of things like the duty cycle of the square wave. You can set the width, the length, even the amplitude of it. You can even select something which is called double pulse, which means that you can send two pulses one after another immediately. I can imagine for certain applications that could be useful, but either way, this board, as it were, shapes, quote unquote, the square wave. Now, I still am not getting square wave at the output. Alright, the output being either here, which is the high amplitude, high voltage output, so up to 20 volts peak to peak, or on the normal output, which is 2 volts peak to peak, which is right here. I am, however, getting some sort of a reaction or a result if I use the amplitude and more than that the DC offset potentiometer. So that does react, but the square wave settings, which are all available here and here, are dead. So they aren't doing anything. Yeah. Now I took a closer look at the board, and a couple of things seem a bit strange to me. Like, for example, this is the power supply of the pulse board, and this is the full rectifier bridge. Now you can see one of the diodes is different from the other three, so which would tell me that probably in the past one of the diodes has had to be replaced. Also, a small detail perhaps is that the voltage regulator, which is a 7805, alright, has heat conductive paste on its back. Now the other voltage regulators, which are mounted here, yeah, and which are the original voltage regulators installed at Wavetek, do not have heat conductive paste. So something is telling me that probably this is also a replacement. So the thing is, the whole board has absolutely no or creates absolutely no change in the output of the Wavetek. Yeah, it's completely dead, electronically speaking. So what I'm going to do next is I'm going to measure the voltage at the output of the voltage regulator and see what sort of voltage we get. Alright, I'm measuring the voltage at the output of the 5 volts power regulator or voltage regulator, which is right here at this strap here, and I'm getting 5.02 volts positive DC. So that's okay. And then I just kept looking at the board, and thinking what the hell could be wrong, until I noticed this. Do you see this yellow wire here? Let me close up a little. So this yellow wire here, yeah, comes from the main board over there. Alright, so point E22 is connected to point E57, which is down there, on the pulse board. Well, normally it should be connected via the yellow wire to that point, and it isn't. So there's something wrong there. If you look at the schematic here of the Wavetek, you see here E22, E57, so yellow. Alright, so the wire for some reason is loose, so I suspect that might be at least one of the causes why I'm not getting any square waves at the output. Alright, I reconnected the yellow wire to E57 and then switched on the whole Wavetek again, and connected the low output, so the output which gives maximum 2 volts peak to peak, to the oscilloscope, and I set the output waveform to square wave, and now this is what I'm getting. I'm getting the square wave. Alright, and I can set its frequency. So it would seem that yeah, that we repaired the Wavetek. I don't wanna cry victory just yet, but I think we're getting close. Yeah, I think what I'll do next is reassemble both boards, and then have a closer look at the last few details that need to be repaired. Like there is the broken switch over there that needs to be repaired, and then I need to replace the broken BNC connector here. After another round of switch cleaning, it seems the whole thing finally seems to work properly. See, we're at slightly less than 3 kilohertz here. Alright, so the whole thing now seems to work properly, but there is one thing that is puzzling to me, which is that the voltage regulators for the main board get extremely hot. I mean, let's say uncomfortably hot. I can barely keep my fingers on the heatsink. You know, it's getting really hot. So I don't know if that's normal, but the device seems to work normally. So I need to read up a little on the maintenance manual, or I should say the service manual, to see whether this temperature level is normal or not. If it's mentioned in the manual at all, of course, but it's really hot. Now I have to say that this heatsink here is normally connected up to the back plate of the Wavetek, which of course provides for even better cooling, I suppose. Yeah, I mean, I'm slightly worried about this temperature level. I placed some thermal conduction pastes on the power regulators right there. Okay, I don't know if you can see it, but so right there, you see? I placed some extra heat conductive paste on the power regulators just to make sure that the heat is conducted away from them into the heatsink. Also, I took out my remote temperature sensor here just to read the temperature. Alright, so see, I don't know if you, yeah, I think you guys can see it. So the temperature is, oh, I would say, depending on the angle that I measure on the heatsink, there you go, 54 degrees C, or almost 55. Yeah. So which is 128 Fahrenheit. Alright. So I would say that's reasonable, as long as it doesn't rise, let's say, over the 60 degrees Celsius, which I think would be somewhere around 135 Fahrenheit. We're golden. We're okay. Also, I looked in my stash of replacement parts, and what do you know? I found a replacement part for the missing button. As you know, there's one button down there broken and lost. Let's see. So right down there, yeah, one of the buttons is missing, and I looked through all the buttons I have, and I actually found a replacement. So what I'm going to do is I'm going to probably glue it with some super glue to the end of the broken switch. Okay, I'm going to remove this sticker here, which apparently is from Siemens AG. I don't know if you can see this. Yeah. So this sticker here, as you can probably see here, is from Siemens AG, which is a German conglomerate which specializes in making all sorts of electronic equipment. So I suspect the Wavetek was at one time property of Siemens, or it was sent into Siemens to have it checked up and maybe, who knows, you know, adjusted a little bit in its settings. Now, either way, I want to remove it because this is not original to the Wavetek anyway. And it is apparently a sticker with glue which holds on for dear life. I mean, I tried the usual method, which is to apply some heat with a hair dryer, you know, but the glue is rather old, and like I said, it's really sticky. So I'm using a far better trick, but which asks a little more patience, which is to use cleaning petrol, you know. So you saturate the sticker, the underside of the sticker, with pure cleaning petrol, you know, like this. Let me show you. Alright, so yeah, this is cleaning petrol, which is basically petrol like you put in your car, right? But without any additives. And petrol and glue do not mix well, meaning that if you saturate the glue with petrol, eventually the glue will lose the battle and release. But obviously you need to be very patient doing this. There is another trick which is perhaps a little faster, which is to fill up a syringe with petrol and then to inject the petrol underneath the sticker. Yeah. In certain cases, especially with large stickers, that works a bit faster. But since this is a very small one, I'm not going to use the injection needle trick. I'm just going to brush a little bit of petrol underneath it for the next 10 minutes or so, and then it should just peel off without any trouble. So give me a moment to show you the result when I'm done. We're almost there. No sooner had I finished recording that the surface area where I could rub in alcohol suddenly became quite large, as you can tell, and the glue started releasing quite easily. So now I can just peel it off, and we're almost there. Yeah. Yeah. We're almost there. Just a little more. Yeah. There you go. voila! See? That's it. As easy as pie. Alright, I'm getting ready to repair the largest break in the housing of the Wavetek, and it's right here at the edge. Alright, now the problem is this edge is beveled, and I mean by that the edge, if you look at it from the side, yeah, is sitting like this at an angle, yeah. And since I'm going to repair with some epoxy glue, epoxy is kind of viscous and runny, so we want preferably the epoxy to harden at an angle so that it sort of retains the same angle of the beveled edge of the original edge, right? So what I did was I built a little cradle consisting of painter's tape, rubber, pure rubber, and little wooden sticks, you know, balsa wood sticks. And where the rubber and the stick is going to come into contact with the glue, I applied a very thin, very thin layer of what was it I used? Oh yeah, silicone oil as a release agent, you know, just to be on the safe side. Now I'm fairly certain the epoxy won't stick to the rubber, not very well anyway, but either way I applied a very thin layer of silicone oil to the rubber and to the little balsa wood stick you see right here. Alright, I'm done. But boy oh boy is this dirty stuff. So I ended up mixing too much, obviously. That's kind of annoying, but it's always the same thing with those tubes. So normally they sell the epoxy glue like a double syringe. Okay, so wait, let me zoom out. So normally they sell the epoxy like a double syringe, and I hate this design because you can never apply equal force to both sides when they're one unit. Okay, so I always end up cutting them in two and then using them as separate syringes to get the right amount of glue on the spot where I want to work. Yeah. So yeah, there you go. I mixed it, and it has a weird sort of metallic gun gray color. But I mean that's logical since they call it like liquid steel or something like that. So yeah. Now is it perfect? No, it isn't. I will probably need to sand a little once it's completely cured. But I mean the essence is that the break is repaired. You know, that broken piece of the edge is repaired. I might have to sand it off and then maybe even retouch it with a little bit of extra glue, but I think this will do nicely. And here is the result. After 24 hours of curing, so they said on the packaging 30 minutes of curing, but I let it cure for a whole day, so 24 hours, and then I wet sanded it. So I cut off wherever there was excess. I cut it off with a breaker knife, and then I wet sanded it with 800 wet sanding grit until it was smooth. And this is the result. It's not black as it were. It's not black, but it's dark gray, and that suits me perfect. I mean, it never was my intention to make it look brand new, okay? But the largest break was here in the front, and this beveled edge is, let's say, the cool part of the whole cabinet, right? So in its cured, unpolished form, this is what it would look like. So I guess you could call it gun metallic gray, and it's pretty tough. It's actually, it's really hard. You know, it has a slightly rubbery feeling. I mean, like, you could bend it a little bit, but overall it has a really strong feel. So I don't think this will ever break again. Also, this was a rubber pad that I used as an underlay underneath, you know, to as it were pour in the glue. And well, the fact that it is natural rubber and that I treated it with a little bit of silicone oil on top, you know, the glue never attached to it, you know. So by the way, the same thing with the wooden stick. You know, the spatula I used as a barrier for the glue, okay. I also treated it with a little bit of silicone oil, and it never got stuck to the glue. Perfect. So what I need to do now is give it a last wipe and then mount it all back. Alright, so all I need to do now is to close up the case. But before I do, I just want to show you a few things that I did, and maybe I didn't show all of it, so I just want to go over it quickly together with you. So one of the things I did was to repair one of the broken switches, well, you know, replacing the missing knob. And I don't remember which knob it was anymore. I should look at the pictures. But yeah, the fact that I don't even see which knob it is I repaired, I think means it's a pretty good job. Yeah. So I replaced the missing knob. I cleaned the other knobs, and I replaced the little set screws that were in them, okay, because the other ones were worn out. I just couldn't get them loose anymore. Well, obviously I could, but it took me a lot of time to get them loose, yeah. So I replaced them with new set screws. I repaired the three damaged, well, I repaired two of the three damaged BNC connectors. They don't look brand new anymore, but they are functional. So these two are functional again. And I replaced the last one here. Now there's a small difference, and I'm sure you can immediately see what the difference is. The old BNC connectors, like this one here, had this plastic spacer, alright, between the front panel and the BNC connectors. Now, unfortunately for me, the replacement BNC connector I used, I don't know if you can see it, but it's down there, okay? So the replacement BNC connector I used was just a couple of millimeters shorter at its back end than the original one. Alright, so I had to forego placing back the spacer, but to make sure that it is insulated from the front panel, I used Kapton tape, which I put all around the edge and the body, in fact, of the BNC connector. Okay, so there's Kapton tape around its edge and around its the back of its body, and I can assure you it's not making any contact with the front panel. I measured it out with my multimeter, and even in the mega ohms there's no short to be measured at all. Okay, so then as you saw earlier in the video, I repaired this massive break here in the case. Okay, and although it doesn't look original anymore, it certainly feels okay, and it looks the part too. Okay, so it was never my intention to make it aesthetically pleasing or anything. I just wanted to repair the brake and to make it functional, and well, you know, to sort of save this beveled edge here of the Wavetek, which is actually one of its cool features, you know. So yeah, I just wanted to repair the beveled edge, and it turned out okay. I used a very tough epoxy glue to do the trick, and I sanded it down with 800 grit wet sanding paper. Okay, so I used 800 grit wet sanding paper for that, and that's, I would say, the more visual things I did to the Wavetek. Now let's see what I did on the inside. Now what I did on the inside is replace all the electrolytics on the main board, which you see here, and of course on the pulse board below, the little PCB you see over there. Alright, so that's the one thing that that's what I did on both boards. Oh yeah, and I also, you know, the power supply wires, so the AC part of the power supply, are the blue wires you see over there, these two here, for the 5 volts, and then these here, these 3 wires here to supply the 30 volts AC to the main board. Okay. So yeah, what I did was, these wires, the AC wires coming from the transformer, they were soldered directly to the board, to the main board. And rather than doing that, I placed some small connectors like this. Okay, so let me pull out one. Okay, so I used this type of connector. Okay, and the reason why I did this is because it makes my life so much easier, so much easier to give the Wavetek a maintenance than leaving the wires soldered onto the board. Yeah, it just makes it so much more convenient to give it a maintenance. Okay, so and the only thing you need to do is pull out the connectors when you want to give it a maintenance, and then just take out the electronic part out of the cabinet, and there you go. So you can even leave the transformer, you know, the back with the transformer in the case if you wish to do so. So it makes it so much more convenient. What else did I do? Oh yes, so I provided a little connector for the pilot light here, which, by the way, used to be a filament light bulb, and I replaced it with a high power blue LED, which is way much cooler, and it consumes far less power too, you know, than a filament light bulb. And I used a little connector system just like for the power supply. Alright, I connected the Wavetek with a pigtail to my scope over there. Okay, and right now the Wavetek is set at 10 kilohertz sine wave signal. Okay, so I don't know if you can see it over there. So the scope says it's 10.10 kilohertz. Okay, so it's even less. It's 10.05 maybe. Let's see if we can get it even more accurate. There, it's pretty darn close to 10 kilohertz. Okay, and if you look at the dial of the Wavetek, you see here it's at the 1.0 setting. Okay, right here. Alright, and I selected the 10K setting. So 1 times 10K is 10 kilohertz, and that's exactly what the scope says it outputs. Okay, so there you go. That's the sine wave. So now let's have a look at the sawtooth signal. Yep. There you go, sawtooth. Okay, so and I can vary the frequency quite easily. Yeah, okay, so let's set it back at 10 kilohertz. Okay, so now let's have a look at the square wave signal. There you go. Now I did set it on double pulse because that's a very funny feature. There you go. So with the double pulse you can send, as the button says, so right here. Okay, so right here, this button here, okay, it says DBL pulse, so double pulse. With the double pulse you can do exactly that. You can send 2 pulses one after another, and with the delay button you can choose how much of a delay there is between the pulses. Alright, obviously at a certain frequency it doesn't really matter anymore, but there you go. So you can set the delay between the 2 pulses. Okay, so you can actually set how many milliseconds or microseconds you want between the 2 pulses. Okay, you can even set the width of the pulses. You see? I can make them needle sharp, so really fast pulses, one after another, or I can increase, well, I can actually, yeah, increase the length or the width of the pulses as well. Alright? Obviously, I can also switch off the double pulse feature. Hang on, which is the delay on. There you go. So that's without the double pulse feature, and yeah, I can select the DC offset. Although the DC offset is a bit bizarre in its shape. This is the amplitude of the signal. All right. The DC offset works, but below a certain level, the shape is not very clean. As you can tell for yourselves. So I don't really like this DC offset feature, but you can switch it off completely, like this. Okay. So this is the DC offset button here. So with this button you can give the square wave or any sort of wave a DC offset, so you can push the signal above a certain level or below a certain level. Okay. Yeah, let's zoom out a little. So you can push the signal above a certain DC level or below a certain DC level. Okay, and you can use this button here for that. This is the amplitude button. Obviously, it's a excuse me, it's at max right here. Okay, and then what I showed you a minute ago, the delay and the width of the double pulses can be set with these two knobs, and you can select a range of delay ranges. Yeah, so you can go from 0.1 microsecond to 0.1 seconds. So a range between, you can choose the delay between the pulses, right? If you choose double pulse. Okay, so there you go. You can do the same thing with the width. Yeah, you can choose between 0.1 microseconds to 0.1 seconds of the pulse width. Okay, so there you go. For the rest, the Wavetek has more or less, I would say, the usual in and outputs you would find on a function generator. So you have a voltage controlled gate in, and this feature actually, if I understand the manual correctly, allows you to modulate the output signal. Okay, so it allows you, in fact, to modulate the signal in frequency or in amplitude. Alright, so that's the VCG in. The trigger in is exactly what it says it is. So if you inject a trigger signal, which is TTL level, 5 volts, alright, so if you inject a positive 5 volt trigger signal, you will cause the Wavetek to output the signal. Alright. The sync out is the reverse. So the sync out will output a TTL level signal, so plus 5 volts pulse, every time it outputs on its output here a pulse signal. Alright, so obviously this is a feature you would probably use only with the square wave function, not so much with the other waveforms. And you would probably use that to test out digital equipment. Alright. So that leaves me only to explain these two outputs here. So this is the normal output, and that goes to a maximum of 2 volts peak to peak, between the lowest and the highest point of a waveform. And it even says 2 volt PP, so 2 volts peak to peak. This is, in fact, you could say the same as this, except that this can go to 20 volts peak to peak. Yeah, and it even says with a maximum of 3 amps. No, sorry, with a maximum of 200 milliamps. Okay, so this goes. This standard outputs 20 volts peak to peak at 200 milliamps, but they also say here 42 volts peak maximum. Alright, so there you go, the Wavetek function generator restored and cleaned, and I bought it rather cheaply. Okay, so this whole machine here cost me, I think, 70 euros, transport included. Granted, it doesn't look very nice anymore. I mean, the case doesn't look very nice. It has had a very rough life, and my guess is this Wavetek has been used in an industrial setting. Yeah, and you can see that it was meant to be a workhorse in some lab or some production hall or something like that. So yeah, it has had a very rough life, but cleaning and repairing it gave it a, you could say, a second wind. Yeah, and these are the parts that I replaced. Alright, so a few electrolytics. I would hazard 10 or 12 electrolytics. Yeah, a BNC connector, a few tantalum capacitors, the pilot light, the original pilot light, and that would be it, I think. Yeah, that's it. So that's what I replaced. Unfortunately for us all, the Wavetek company went bust in the late 80s, if I'm not mistaken, in 1988. Yeah, which is a shame, because actually they made some pretty good equipment, some really good equipment. So it's a pity their company went bust, but I guess they just couldn't keep up with the evolution in electronic technology, in measurement and regulation technology of the day, So electronics made a huge jump forward in the 90s, especially with the advent of SMD electronics, like the tiny little parts that they nowadays use in such equipment. Yeah, they just couldn't follow anymore with the evolution in electronics. But this equipment is still available, still works great if you clean it and maintain it and repair it. And it's certainly a cheap uh, let's say a cheap alternative to new equipment. So if you have a low budget, if you're lucky, you can even get these nowadays for less than 50 bucks. Okay, and if you put in some work into it to repair it and clean it, it would cost you maybe an extra 10 bucks, and then you have a really great instrument for your lab. Okay, the Wavetek model 187. I hope you enjoyed the restoration of it, or I should say the repair of it, and I'll see you soon for another video on my channel. Thanks for watching.